Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual in the ghost mode, Mohit Jain. The process, the pattern we have already discussed in our first part. Link is there in the description below. Please go through it. So without wasting any time, let's start now. Today's session is more about permutation, combination, and probability, and the question which we have repetitively seen at TCS Digital. We are starting with the basic. Give it a try. There are 10 men and 11 women in an office. In how many ways can a team of 5 men and 4 women can be selected? Out of 10 men, we need to select 5. That can be done in 10C 5 ways. And out of 11, we need to select 4. That's it. We just need to solve. We know NCR is factorial n upon factorial r factorial n minus r. This factorial 10 by factorial 5 into factorial 10 minus 5 is 5 into factorial 11 by factorial 4, and 11 minus 4 is 7. Yes, factorial 7. Just we need to solve it. You can use on-screen calculator if you want. On calculating, it would be 83,160. So 83,160 ways are there to form a team of 5 men and 4 women from 10 men and 11 women in an office. This is a theta type of question. Theta means type in the answer. A box would be given to you below the question. In this box with the keyboard, you need to type 83160 in it. No units are typed, only number are typed basically in theta type of question. So we will be typing 83160 and move on to the next one. Classical take on digits, give it a try. So let's see what we have here. A password length 5 is to be created. Okay, using different digits from 1, 3, 5 and 7, and exactly one digit is to be repeated exactly 2 times in consecutive positions only. No other digits repeated. Very good. How many numbers of such password are possible? Suppose digit 1 is repeated. So we will have a password of type this 11357. So we have, actually, if you look carefully, we have only 4 digits with us. Because 1, wherever you are putting this 1, they should be in the consecutive position. So let's group it up and treat them as 1 unit only. And since both are 1, there is no need to permute it, because 1 when permuted will always give 1. So if you see carefully, we have got only 1, 2, 3, 4. 4 digits in this case. Clear? And in this 4 digit would be permuted in how many ways? Factorial 4 ways. That would be 24. Similarly, I can also have 3. 3 as the repeated one. I can have 1, 3, 3 together and 5, 7. This also would give me 24 cases. With 1, 3, 5, 5, 7, also 24 cases. And again 1, 3, 5, 7, 7. Also we will have 24 such different cases. And these 24 cases will be different from these 24 cases. Isn't it? So total number of cases possible are 24 into 4. That is 96. In the box given, we will type 9696, and that should be the answer. Take on circular arrangements, give it a try. Okay, before we move into this particular case, 2 concepts in case of circular permutation. If n people are arranged in a form of a circle, n different people, I'm talking about people, they can be arranged in factorial n minus 1 ways. And if suppose out of this n people, g people want to stay together in the circle, g people or the group size is g want to stay together in the circle, then they can be arranged in factorial n minus g plus 1 minus 1 into factorial g ways. That would be simply n minus g into factorial g ways. This is in case of circular permutation. If n different people need to be arranged in a circle in factorial n minus 1 ways, out of which g people wants to stay together always, then the number of ways of arrangement would be factorial n minus g into factorial g. This is only in case of circular permutation. Now, let's come back to our situation. 8 people sit around a round table, each facing the center. If A does not sit adjacent to B, then in how many ways they can sit around a table? Suppose there is no restriction, then number of ways 8 people can sit together or 8 people sit around the round table are 8 minus 1 factorial. That is factorial 7. Factorial 7 is 5040 ways. But we can see here that A is not sitting adjacent to B. That means let us find out the ways where A and B are sitting together. That means in this case G group size is 2, N is 8, G is 2. So in how many ways 2 people can sit together in a circle? Factorial n minus G into factorial 2. So that would be factorial 6 into factorial 2. That is 720 into 2. That is 1440. So there are 1440 ways where A and B are sitting together. But in the question they have asked that A will not sit with B. So it would be total cases minus A and B together. That would be 5040 minus 1440. 004360. In the box given, we will type 3600. In 3600 ways, this can be done. One more situation on your screen, you know the drill. Pause and try to solve it yourself. Okay, let's see. In a team, there are 9 Indian players and 7 foreign players. Rules allow at most 5 foreign players in the playing 11. In how many different ways a playing 11 can be formed in this team? So maximum we can have 5. We can also have 4. We can have 3. We can have 2. We can have 1. We can have 0. I'm just putting up all the values and let's see, can we have this or not? Because total number of players should be 11. 11 minus 5 is 6 Indians. 4, that means 7. 3 is 8. 2 means 9. 1 means 10, but we don't have 10 Indians. That means only these 4 cases are possible. Great. So if we choose 6 Indians and 5 foreign players, in how many ways this can be done? It is 9C6 into 7C5. 9C7 into 7C4. 9C8 into 7C3. 9C9 into 7C2. 4 cases. 9C6 is 9 into 8 into 7 by 3, 6. And 7C5 is 7C2, 7 into 3, 21. 3, 2, 4. 84 into 21. 84, 21, 4, 8, 8, 16, 1, 1764. Or 9C7 is 9C2, 9 into 4 is 36, and 7, 3, 35. 35 square 1, 2, 2, 5 plus 35, 50, 60, 1260. 9C8 is 9, 7C3 same as 7C4. That is 35. 315. And then 9C9 is 1, 7C2 is 7 into 321. So total number of cases should be 0, 1, 12, 13, 14, 15, 16, 1, 8, 9, 10, 13, 1, 3, 3, 6, 0. In how many different ways playing 11 can be formed is 3, 3, 6, 0 and type in the box given. If you are not comfortable with solving these 4 different cases, you can solve 3 cases. What would be those 3 cases? We have got 9 plus 7, that is 16. 16C11. From this total number of cases, deduct where you have 1 foreign player, which is not possible. You have 6 foreign players. That means 7C6 into 9C5 and subtract where you have all foreign pairs. 7C7 into 9C4. And you will see that you end up getting the same result. So on calculator value, we get 16C11 is 4368 minus 882 minus 126, and that is equals to 3360. So either of the format you can choose. This is the straight way of doing it, and this is from the total cases we are subtracting the cases which are not possible. Answer is 3360. Let's move on to the next one. Solving few classical takes so that we can revise all the formulas. Do it. So what's the case? How many 4-digit even number can be formed with the digit 1, 3, 4, 5, 6, 8 if the digits can be repeated? That means in this unit place we can have only 4, 6 and 8. We have got 4, 6 and 8. 3 options for this particular unit position. For other position, any digit can be placed in these position, and since repetition is allowed, we have 1, 2, 3, 4, 5, 6. 6 P1. Here also 6 P1. Any one digit out of 6. Any one digit out of 6. And here only we have option for 3 digit. It would be 3 P1. So it is simply 6 into 6 into 6 into 3. That is equals to 6, 4, 8. Put it in the box, and that is the simple answer. A classical take on learning arrangements. Do give it a try. Pause and do give it a try. There are 3 violet, 4 yellow, and 5 orange card. In how many ways these cards can one arranged such that no 2 violet cards are adjacent to each other? Wherever we have these kind of question, we use a special technique which is known as gap analysis. Generate gaps and then put in the objects. Priority is on violet cards that no 2 violet cards are adjacent to each other. Done. Leave this. Arrange these things. Arrange 4 plus 5, 9 cards. And forget about the violet cards. These 9 cards can be arranged in factorial 9 by factorial 4, factorial 5 ways. How? Because 4 yellow cards are of same type and 5 orange cards are of same type. So let's find this value. 9, 8, 7, 6 by 4 is 24. 3, 3. So this is 21 into 6. That is 126. So in 126 ways, these 9 cards can be arranged. Now can you see these 9 cards? 1, 2, 3, 4, 5, 6, 7, 8, 9. These 3 violet cards can be placed in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For placing these 3 violet cards, we have got 10 places, and these places are between the gaps. That's why I call it gap analysis question. So in how many ways these 3 people can be arranged in these 10 open places is 10p3, but divided by factorial 3. Why we are dividing by factorial 3? Because these 3 are again a like item. So 10p3 is 10 into 9 into 8 divided by 6. 3, 2, 4. This is 120. So total number of arrangements are 126 into 120. And that is 15120. Put this in the box and move on. Moving on with probability and classical take with arrangements and the concept of probability. You know the drill. Okay, let's check. A bag contains x plus 5 yellow balls, 2x plus 1 blue balls, and some red balls. If 2 balls are drawn one after another from the bag without replacement, it means we can use the combination technique. If it is without replacement, then the probability of getting a red ball and a blue ball is 1/6. Total balls in the bag are 4x plus 8. So number of red balls would be x plus 2, isn't it? Now, probability of getting red and a blue ball, so drawing one red ball from x plus 2 C1, that is x plus 2, and then one blue ball from 2x plus 1 is 2x plus 1 C1, that is 2x plus 1, divided by, from the total we are drawing 2 balls. So it would be, and we know NC2 is n into n minus 1/2. We can use it. So it is 4x plus 8 into 4x plus 7 divided by 2. Let me take it to the numerator. This is equals to 1/6. Okay, 2 cancel this, 2x plus 4, and then it will be x plus 2 3 times. We just need to solve this and we need to find the value of x. 3 into 2x square plus 5x plus 2 equals 4x square plus 7x and 8, 15x plus 14. Let's solve. 6x square minus 4x square, 2x square, 15 and 15 gone, plus 6 equals to 14. So 2x square is 8, x square is 4, x equals to 2. Positive value of x would be 2. Now the question is, find the number of red balls. Find the number of red balls. Number of red balls are x plus 2. That is 2 plus 2, 4. Option B is the pick. Classical take on digits, permutation, probability, give it a try. Digits, classical take. A 5-digit number is formed by the digit 0, 2, 3, 5, 7 without repetition. Stop here. Let's see how many 5-digit number we can form. See, if we have n digits where 0 is not included and repetition is not allowed, then r-digit numbers, how many r-digit numbers we can form is simply NPR. This is case 1. Case 2, if we have got n digits and 0 is also included in those n digit and repetition is not allowed, then how many r-digit number we can form is NPR minus n minus 1 PR minus 1. These are the two cases for repetition not allowed. So here we have got 5 digits, 1, 2, 3, 4, 5. And we need a 5-digit number, but 0 is also there. So total number of cases would be simply 5p5 minus 5 minus 1, 4p4. That is 120 minus 24, 96. Total 96 5-digit numbers we can form. Now, what is the probability that the number formed is divisible by 4? A 5-digit number is divisible by 4 only when last 2 digits are divisible by 4. So let's check what different combination we can have such that the last 2 digits are divisible by 4. If I start with 0, 02, 03, 05, 07, no, nothing. Then with 2, 20, 20 is divisible by 4, 23, 25, 27, 3032. Then with 5 we have 52. Then with 7 we have 72. So we have got 4 options which we can put in the last place, and then the number would be divisible by 4. Now, if I take 20 at the last 2 digits, then I can see that in these 3 positions, I'm left with 357, and these 357, 3 digits need to be arranged in 3 different places where 0 is not there. In how many ways? Factorial 3, that is 6 ways. We can have 6 5-digit number which end with 20. Now, second case where the last 2 digits are either 32, 52 or 72. Out of these 3, only one we can take here. So how many cases we can have here? 3p1, that is 3 case. Now, in the leftover 3 places in the beginning, if I take 32, I am left with 057. If I take 52, I am left with 037. If I take 72, I am left with 035. That means in any case, 0 is also included. So 3 digits are available, out of which 0 is also included. In how many ways we can place this up in 3 different places? Again, this formula, 3p3 minus 2p2. How many cases are there? 3 cases. 6 minus 2 into 3. 4 into 3 is 12 ways. So how many 5-digit numbers we can have which ends with either 32, 52 or 72? We have got 12 of such numbers. 6 of such number ends with 20. So total 5-digit number that can be formed with 0, 2, 3, 5 and 7 without repetition such that those are divisible by 4 are 6 plus 12, that is 18. So out of 96, 18 are divisible by 4. So what is the probability that the number formed is divisible by 4? Required probability is simply 18 by 96. And let's check what is its value. It is 18 by 96 is 0.1875. 0.1875, and that is in option A. Okay, we are starting with classical questions on boy and girl, children in a family. Give it a try. The probability of having at least one girl and one boy in a family of 4 children, assuming equal probability of male and female birth, is at least one boy and one girl. That means it is simply total cases minus all boys case minus all girl case. So if there are 4 children in a family, total number of cases would be 2 to the power 4. 2, 4, 8, 16. All boys cases would be 1. All girl cases would be 1. All boys case means B, 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 B. All are boys. All girls case means G, 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 G. So if I take out these cases of all boys and all girls, I would be left with all those cases where there is at least one boy and one girl. That means effective cases we are looking out for is 14. So the required probability is 14 by 16. That is 7 by 8. 1 by 8 is 12.5. That would be 87. 0.8750. Option B is the pick. Combination of algebra with probability Quadratic equation concepts. Let's do it. The probability of choosing randomly a number from the set such that the quadratic equation, randomly a number इसमें k ही होगा, such that this particular quadratic equation is real and distinct roots. So if we have a quadratic equation ax square plus bx plus c equals to 0, it will have real and distinct roots only when b square is greater than 4ac, or b square minus 4ac is greater than 0. If it is equals to 0, then roots are real and equal. So here b is minus 6, a is 2, and c is actually k. So b square is 36 is greater than 4 into 2 into k, 4, 9. So we have got 9 is greater than 2k. If I divide both sides by 2, 4.5 is greater than k. Value of k is less than 4.5. So out of these given 9 values, favorable values of k can be 1, 2, 3 or 4. So favorable values are 4, total values we have 9. So probability, required probability is favorable cases by total cases. 4 by 9, that is 0.44444, whatever. Option B. Check this one. A number is chosen at random from the first 80 natural numbers. That means from 1 to 80. What is the probability that the number chosen is multiple of 3 or 5 or 7? So total number of cases are 80. A union B union C is A plus B plus C minus AB minus BC minus CA plus ABC. We can use it. How many numbers are divisible by 3 between 1 to 80? 80 by 3, box function. Divisible by 5, 80 by 5, box function. 80 by 7. Divisible by both A and B, 3 or 5, that is 15, box 80 by 15, minus B and C, 5 and 7 is 35, 80 by 35. CA 7321. I'm just writing everything, but you are not supposed to write all this thing. You just solve and write the value directly. Plus ABC 3, 5, 15 and 7 is more than 80. So it would be 0. There is no number which is divisible by all 3, 5 or 7. So now we just need to write the box function, highest value function. That's it. 80 by 3, 26. Plus 80 by 5, 16, 80 by 7, 11, minus 80 by 15, 5, 80 by 35 would be 2, minus, this is also minus, 80 by 21 is 3, that's it. And now see what we have, 26 plus 16 plus 11, minus 5, minus 2, minus 3, that is 43. So there are 43 numbers between 1 and 80, including both, which are either divisible by 3 or 5 or 7. So required probability is 43 by 80, just greater than 50%. It should be 5375. Let's check. 43 by 80 is 0.5375. That is in option B. A classical take again on probability and probability theorems. Give it a try. Okay, let's see this, and I hope that you people would be practicing these kind of similar kind of questions, because permutation combination probability questions are very regularly asked at TCS Digital on campus. So please go through it, and also go through part 1, part 2, part 3. Link is there in the description. Please go through it. Let's see this one. A basket contains 15 apples and 25 oranges, out of which 4 apples and 6 oranges are defective. So non-defective would be 11, and from here we have got 19. Done. If we choose 2 fruits as random, what is the probability that either both are oranges or both are non-defective? Now the thing is, when it is not given that whether the 2 fruits which we are choosing is with replacement or without replacement, we will always consider that as without replacement. That means we need to use combination techniques. So first, find the total number of cases. Total number of cases would be 20, 30, 40, 40 C2. That would be 40 into 39 by 2, 20 into 39. Done. Now, they are looking out for both are oranges, OR, or means union. Both are non-defective, ND. A union B is given by PA plus PB minus P of A intersection B. So first we'll calculate what is the probability that both are oranges. We have got 25 oranges. It would be 25 C2 by total 40 C2. Let's write this first. Probability that both are non-defective. How many non-defectives we have? 1, 2, 3, 30. So it is 30 C2 by 40 C2 minus. These are oranges and non-defective. Oranges and non-defective oranges are how many? We have 19 minus 19 C2 by 40 C2. Now let's calculate this. 25 C2 is 25 into 24 divided by 2. That would be 25 into 12, 300. Plus 30 C2, again 30 into 29 divided by 2, 435. Minus 19 C2, 19 into 18 divided by 2 is 171. By 40 C2 was 20 into 39, that is 780. So how much we have? 300 plus 435 minus 171 is 564 divided by 780. Now here we can see that we have got a 65, 780 is divisible by 65. So it is 65 into 12 and 564 divided by 65. No, 564 divided by 12, we are getting 47. This is 47 into 12. Done. It is 47 by 65, which is in option D. Use of probability theorem and concepts. Do practice it. It would be required. Mohit Jain signing off from MJ's Maths and Stats, and I'll see you soon. In case of any doubt, please do ask.